Next we have the square planar complex of the type MAAA2. So there is a didentate ligand you can see, and there is a unidentate ligand, and the unidentate ligand is present twice. So again there is only one didentate ligand, okay, that means there is only going to be one ring. So again the trans pair rule will apply, that is you cannot keep AA in the same trans pair, they have to be in different trans pairs. So again this is a possible pair, and this can only be the possible pair. You can see that there can be no other possible pairs in this case. In this case A is trans to A and A is trans to A. So when we talk about the number of geometrical isomers, it is going to be 1. But if you are asked will this compound or complex show geometrical isomerism, you are going to say no. This complex is not going to show any type of geometrical isomerism. Is it going to show any optical isomerism? Again no, because it is a square planar complex, it is not going to show any optical isomerism either. So that was one. So as the enantiomeric pairs depend upon the number of optical isomers, so enantiomeric pairs is also 0. Therefore the number of stereoisomers is equal to the number of optical isomers plus the number of inactive pairs, so that is 1. So the total number of stereoisomers is equal to 1. So these are all the possible isomerisms exhibited by the square planar complexes of the type MAAA2. Next up we have the same type of complex. In this what we are changing is that the didentate ligand does not have the same type of donor atoms, it has different types of donor atoms. But the overall thing is the same. So again the possible pairs is again going to be the same. So trans pair rule applies here also, that is the didentate ligand donor atoms, they cannot be in the same trans pair. So only this possible pair is possible. In this A is trans to A and B is trans to A. So the number of geometrical isomers will be 1. The number of optical isomers is going to be 0. The number of enantiomeric pairs is again going to be 0, and the number of stereoisomers is going to be 0 plus 1, which is equal to 1. So these were all the isomerisms exhibited by the complex of the type MABA2. Next we go on to other square planar complex. The next square planar complex is MAA2. Again we have AA2, so a didentate ligand is present twice. So coordination number 4 is satisfied on its own, we do not need any different kind of unidentate ligand. And again you can put the AA in a same trans pair because you get 2 rings. So you get this possible pair on only this possible pair. A is trans to A is trans to A. So if they ask you whether it is going to show any geometrical isomerism, the answer is no, it is not going to show any geometrical isomerism. The number of geometrical isomers will be equal to 1. The number of optical isomers is going to be 0. The number of enantiomeric pairs is again going to be 0, and the number of stereoisomers is going to be 0 plus 1, which is equal to 1. So this was the square planar complex of the type MAA2, in which a didentate ligand which had the same type of donor atoms was present twice. So the number of geometrical isomerism, that is the number of possible pair, was only 1, but it does not show any geometrical isomerism as of its own.